Hi everyone, my name is Reshma. I'm part of the MMED team and I'm currently based at the University of Cape Town. I'm going to be speaking about study design and analysis in epidemiology. This is the second lecture of 2 lectures in the series. The first lecture provided a broad introduction, different types of study designs were discussed, and common measures of disease occurrence and association were presented. In the second lecture, I'm going to be talking about a particular type of study, namely clinical trials. And even within this, I'm going to be talking about a specific design. If you haven't watched the first lecture, now is a good time to pause and first do so. This lecture is recorded in 3 parts, so there are 3 separate videos. I'd like to thank my MMED colleagues for some of the content in this lecture. To get the most learning from this lecture, I encourage you to engage with the content as you go. To try to help achieve this, you'll see that on some slides there are red alarm clocks. This is where I suggest you hit pause to take some time to think about the question posed before you continue. Now, before even getting into the outline of this lecture, I'd like to present 2 example studies that we are going to be using. Starting with the first study, suppose a new supplement is being advertised, and we want to know the impact of this new experimental immunity-boosting supplement on a person's risk of having any severe illness. Companies are excited about this new drug because it could reduce the work time lost by employees taking sick leave. And so, at a particular workplace, at no cost, management offers employees access to the supplement, and then for 6 months records any illness in the treated versus untreated people. They find a 30% reduction in illness when treated compared to when untreated. The question I want to pose to you is, would you use the supplement, and do you have any concerns about this estimate? Take a moment to think about your answer before moving on. The challenge here when interpreting the results is that volunteers may be different in some way from those who do not volunteer. For example, your volunteers could have been younger on average compared to people selected at random from the workplace. It might also be that your volunteers were people who were more interested in their health. Because of their interest in their health, they decided to try the supplement, but they are also taking other precautions to stay healthy at the same time. So now when we look at the results, one needs to ask, was the lower mortality observed because the participants were volunteers who were, for example, younger, or because the treatment actually worked? And it's difficult to answer this question from the information we have. Moving on to the second study, a researcher developed a treatment that he felt could alleviate symptoms for a specific chronic condition. He selected a group of participants and provided the treatment over 6 months. He found that symptoms measured at 6 months were reduced compared to symptoms measured at the start. I pose a similar question here. Would you use the treatment? Again, take a moment to think about your answer before moving on. The difficulty here is that we do not know whether there are other reasons why people's symptoms reduced from the start to the end of the study. We also know very little about recruitment in the study. People with certain chronic conditions can have good spells and bad spells over time. If the researcher recruited people having bad spells, for example because he recruited patients coming into care, then we would expect to see them return to their average level of symptoms over time. Another possibility is that participants were people who had just acquired the illness, and this could simply be the natural cause of the illness. So upon acquiring the illness, symptoms are acute, and as your body fights the illness, symptoms reduce. It could also be that participants were just relieved to be trying a treatment, which led them to experience their symptoms differently over time. There are many possible explanations for the reduction in symptoms, which leads us to a different question. Was the reduction in symptoms due to the treatment? And again, it's difficult to answer this question from the information we have. Keeping those studies and their challenges in mind, let's dive into this lecture's content. Starting with the goals or learning objectives, by the end of this lecture, we want to be able to define confounding, describe randomized controlled trials and the central design elements, and discuss the limitations, bias, and variability of results from trials. On the last point, much of what we discuss is applicable to other study types too. Let's begin with confounding. Going back to the first study, we were unable to answer whether mortality was lower because the participants were volunteers or the treatment actually worked. And the reason for this is confounding. Confounding is a concept that's relevant to causal inference, i.e., when we are trying to estimate the direct impact of an exposure on an outcome, in this case, of treatment on mortality. In a particular setting and in a particular analysis, there is confounding if the relationship or association that can be measured between the exposure and the outcome is not equal to the causal effect. And this is typically because there is some common cause of the exposure and the outcome. Going back to our example, suppose that in fact age did influence whether a person chose to use the supplement or not, with younger people being the ones who generally opted for treatment. Younger adults also generally experience lower mortality rates than older adults. This would mean that even if there was no treatment effect, treatment will still be seen to be associated with lower mortality. To explain that a bit more slowly, in our example, younger people are more likely to have the treatment. And so the treated group will have relatively more younger people than the untreated group. And because younger people have lower mortality, this then means that the treated group will also have lower mortality. More generally, confounding can distort relationships in different directions and to different extents. Defining confounding a bit more technically, confounding occurs when there are backdoor non-causal paths between the exposure and outcome. We use the example of age, however there may be many other confounders. Perhaps one's attitude to their well-being is also a confounder. People who worry about their well-being may have tried the supplement. Those people may also exercise more, which affects their mortality. And so there's a relationship between treatment and mortality through a person's attitude about their well-being. Wealth often plays a big role in health outcomes. Wealthier people generally have better access to healthcare, which can reduce their mortality. Wealthier people often also have more free time, and so, for example, could travel to the pharmacy to fetch the supplement. Again, a path is created between treatment and mortality. There are methods to account for confounding in the analysis stage, for example, stratification and adjustment. With stratification, here we would divide the participants into strata of similarly aged people, and then we would study the treatment-mortality relationship within each of these strata. Because age doesn't vary much in a stratum, we would then be estimating the treatment-mortality relationship. Adjustments are usually done when data are analyzed using regression models. Confounders such as age are included as variables in the model, allowing one to estimate the treatment-mortality relationship when comparing similar people, here when comparing people of the same age. But we cannot always adjust for confounders in an analysis. Can you think of reasons why? Sometimes it's that we know how confounding occurs, but we have not or cannot measure all of the confounders. For example, perhaps we weren't able to have a measure of wealth. At other times, we just do not know what other confounders there are, and we have unknown confounders. Since confounding can't always be handled at the analysis stage, we should be trying to avoid it at the early study design stage. And this leads us to randomized controlled trials, which we will discuss in the second part of this lecture. When you are ready, you can move on to the second video. I'll see you there.